Okay, now I want to consider these 5 questions on the board, and they are very simple. Okay, they are very simple. Now, how can we find solution to them? Okay, we have to consider them one after the other. Now, we have the first one. We have 3 root 5, and there is a square outside. Okay, it simply means that the square affects 3 is also affecting root 5. Now, what I will say is that 3 share the square, root 5 also share the square. That is a 3 squared times root 5 square. Both of them are sharing it. Can you see? Now, 3 squared simply means 3 times 3, which is 9. And this one here, you can see there's a root, there's a square outside. Whenever you have a square and a root, both of them can go. Okay? Mean that square can kill root. Now, what we have there become 5. What we have there become 5. 9 times 5 is 45. It means that this one becomes the final solution here. This one becomes the final solution here. 45 becomes the answer. Okay, now consider the next question. We have 2 all over 3. Now, this one is a fraction and is a surd at the denominator. The denominator contains a surd. Whenever you have a fraction and there is a surd at the denominator, what do? Use that denominator to rationalize the fraction. Right? You see now, use this 3 to rationalize this fraction. Now you do that, you simply take 2 over 3. Now use the 3 to multiply the numerator and also use to multiply the denominator. Now, if you multiply here now, you can see that 2 has no roots, but 3 has roots. Therefore, these 2 cannot multiply 3 directly. Therefore, it becomes 2 root 3. Here, it becomes 2 root 3. Okay. Now, let us consider the one at the bottom. We have 3. There are 3 times 3. Both of them has roots. Therefore, okay, since it's a common sort, we can now multiply them, and in the end we have a perfect square. Or we have a rational number, either a perfect square or a rational number. You mean that 3 times 3 is 9. 3 times 3 is 9. Okay, now for this one I can see now 2 root 3, okay, all over root 3, because the root of 9 is 3. The root of 9 is 3. Remember I told you that 9, the root of 9 is a rational number. The root of 9 is a rational number, or we call it a perfect square. Okay, remember I told you that all perfect square are a rational number. You take note of that. All perfect square are rational number. Root 9 is 3. Become 2 root 3 all over 3. That will become the final solution there. Now let us consider the next one, which is question C. We have 6 root 3 all over root 2. Okay, now to do this, we still have a surd at the denominator. For this one, question C, we have surd at the denominator. Therefore, we still use that surd to rationalize the fraction. Of course, we have it like this. We have 6 root 3 all over root 2. Okay, now use the surd now at the denominator to rationalize the fraction. I will say 2 root 2 all over root 2. Use to multiply numerator and also use to multiply denominator. Now, multiplying the numerators. Now, what do we have here? Remember here is invisible 1. 6 times 1 is going to be 6. And this one becomes root 3. Now we have a different surd. This one is 3, this one is 2. Meaning what do? We take a single root and therefore we multiply the 3 and 2. 3 times 2 becomes 6. It becomes 6 root 6. Okay? Now for this one we have a common surd. Root 2 and root 2 they are common. Therefore it will produce a rational number. It will produce a rational number or a perfect square. Okay, now for this one, I will have root 4. Okay, don't forget that all perfect squares are rational number, and root 4 is going to be 2. Therefore, for this one, I will have 6, root 6, all over, okay, all over 2. Okay, do you know that 6, that 2 can share 2, become 1. That 2 can share 2. And you say 2 divided 2 is 1. Okay, 2 can still divide 6, become 3. Therefore, my final solution becomes 3 root 6. That one becomes my final solution. This one is now my final solution here. Okay, now let us consider the next one. I think we can consider the next one. Yes, of course. Let us look at the next one, which is question D. Okay, 2 root 3 all over 3 root 2. Now, can you see now, we have a surd again at the denominator. Look at it, we have a surd at the denominator. Now, what do? We have to rationalize this very fraction using the one we saw under, that the very one under to rationalize. Now, what we have under is 3 root 2. 3 root 2, they are together. They are together. Therefore, we take them together. Now, therefore, I will have to use this one to rationalize this very fraction become 2 root 3. Okay, by taking the original question first. Okay, 3 root 2. Now, using this one to rationalize the fraction become 3 root 2. Okay, 3 root 2 all over 3 root 2 all over 3 root 2. This is what I have here. Now multiply there, 2 times 3 is 6. Now multiply this one, taking a single root first. Take a single root first. Now what do we have here? We have, okay, we have 6. Here we have 6. Here we have 6 roots. Here we have 6 roots 6. Okay, that's for the one at the numerator. The one at the numerator is 6 root 6. Okay, for this one we also multiply, become 9. Here become 9. Okay, we have here as 9. Okay, now we have, okay, I'm coming. Okay, for this one we have 9. We have 9, that 3 times 3 is 9. Why this one? It will give us a rational number. Therefore, we call root 4. We have root 4. Okay? We have root 4. That's what we have there. Now, for this one, we have to still move further and solve. Okay? Now, we can cancel. That is to say 3 can enter 6, we have 2. Meaning 3 can share 6, we have 2. 3 share 9, we have 3. Therefore, we have here 2 over 3. Okay? Here we got 2 root 6. 2 root 6 all over. And this one here is simply, the root of 4 is simply 2. Okay? At the end, we are going to have 2 root 6 all over 6. Okay, we can still reduce again. We can still reduce again. Of course, we can still reduce again. Meaning that for this one, we are going to have 2 here is 1, 2 here is 3. Therefore, we are going to have root 6 over 3. This one becomes my final solution. For the one of D, we have the final solution as root 6 all over 3. Therefore, can you see now that at the denominator, we have a single number, a single integer. It is not a surd. Therefore, we can stop at that point. But if at the denominator we still have a surd, meaning the denominator still contains surd, we need to still resolve further. Okay, now for this one we are okay with that. Okay, then we now consider the last question. We have the last question, that is question E, and we have 50. We have 50 all over 12, and there is a common root. There is a common root. Now, what can we do to this? Don't forget that the root affects 50. And also affects 12. Please don't forget that. Also affects 12. Can you see? The root affects 50 and also affects. Okay, it's possible for us to reduce. Let us reduce first. Now, what can we do here? We can reduce. Now, let us reduce this one and reduce this one. 2 here, we have here, 2 here is 25. Okay? 2 there is 25. Okay? And 2 here is 6. Okay. Now, do you know that we can now, don't forget that the roots affect 25. That is, we have the root of 25. And also, we have the root of 6. We have the root of 6. This is what we have here. Now, what can we do again? We need to still move further. Look at the numerator. The numerator is a perfect square, or we call it a rational number. Therefore, root of 25 is 5. It is not a surd. Don't forget that root of 25 is 5. Okay? And 25 is not a surd. Okay? We can now say now 5 over root 6. Do you see now, at this point, we still have a surd at the denominator. Please don't forget, whenever you have a fraction, and the denominator contains a surd, you have to rationalize. Rationalize that to the fraction. Now, to rationalize this now, this fraction, we simply say, therefore, simply say 5 over root 6. Using the root 6 to rationalize it, become 5 over root 6 times 5, okay, times root 6 all over root 6. This is what we mean. Okay, now multiplying this one now, we are going to have 5 root 6. Okay, for that one, this one here, 5 root 6. And we also multiply this one. This one is a common sort. Don't forget, therefore, we are going to have a rational number or we have a perfect square. Therefore, for this one becomes root 36. Root 36 is 6. Don't forget that. Root 36 is 6. Therefore, we now have our final result as 5 root 6 all over 6. This one becomes your final result. Okay, I think we are okay with this very one. Okay, we are okay with this. And we understand it. We understand it very well. At this point, we can now stop here so that we can proceed further to other questions. Okay, I think we can now call it a day here. We can call it a day here. Okay, in my next class, we are going to consider further example and we are going to solve them. Please just keep the class with me and make sure you are on the platform, the Jobu Online Mathematics. And don't forget to subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best.